Do I even need this? Yeah, probably yes. For okay, great. Thanks for being here. I am Matthew. I'm a product manager at Celo, where I am working on the liquid staking protocol that we have built. So over the last couple of months, we've built like the first version of this, which is the MVP, where the main goal was just to build it up as quickly as possible, and at the same time have some minimum reliability regarding like security, decentralizations for user in place, but then to build it out into a real DAO over time. And so basically what I want to explore in this talk are like different design decisions that we need to take to optimize, along this route for time and also decentralization, and basically give some input on how you can, implement a large part of what a DAO is about with only a small part of the effort that is needed to really build it out 100%. Okay, so the talk is going to be in 3 parts. So first, a quick Celo primer about Celo consensus and the staking process for users. It is a proof-of-stake network, but there are some peculiarities regarding how the staking works, and therefore, yeah, it makes sense to spend a few minutes on that. Then I'm going to talk about that first version that we've already built and which is live since a couple of months, so the MVP, where the goal was to launch as fast as possible. And the main trade-offs are around, well, speed versus these minimum requirements for decentralization and security in the end for the users. And then the third part is going to be around the DAO, where the core goal is more decentralization, and where the trade-offs are mostly around, well, the ease of use, implementation complexity, how much time we have to spend in actually building this all out. Okay, regarding consensus, Celo is a proof-of-stake network. It's already live, like since a couple of years. Celo holders, so that are these users, they don't run nodes themselves. Nodes are being run by independent people, but then users of Celo, they can stake the Celo and then vote for validator groups. And validator groups are groups of individual validators. So these validator groups have like 1 to 5 validators in themselves, in a group. So basically what you need to know is, well, it's proof of stake, and that the Celo holders, they vote for these validators and they don't need to run the nodes themselves. So basically what in Ethereum is only possible through the liquid staking protocols like Lido and so on, namely that you only stake and take some votes for different validators. I mean, in Rocket Pool, you can do that. In Lido, not. It's indirect. That is already possible in the core layer 1 of the Celo protocol. Yes. So let's look at a few traits of these validator groups. So this is just from a table where we can see which validator groups are currently elected, participating, and so on. So you have on the left-hand side first the name of the validator group. So you see here, like, these are all big brands, right? Bison Trades, Figment, Anchorage, A16Z, T-Systems. Well, I mean, T-Systems is not that well known in blockchain, I guess, but it's a big company. They're a big investor in Celo, but also in a few other blockchain protocols. And the other ones are just like big in crypto generally. And what is interesting, if you go to the very right of the table to uptime, you can see that even like these big validators are not really having the uptime that you would expect from them. Like the validators with the most amount of votes, they only have 88% uptime. So this uptime score doesn't really only mean uptime. There is a bunch of other things in there as well. But it's kind of like a health score for the validator. So what you need to know is basically that building out the liquid staking protocol, we cannot just like take the top 5 validators and be sure that they work perfectly. You need to really think about which ones that you elect. And then the second point is about the number of votes, right? So the three columns in the middle, percent of max votes received, number of votes received, max votes receivable, are about how many staked sellers are currently voting for these individual validators. So every validator has a maximum number of votes that they can receive, and basically afterwards, anybody voting for them doesn't earn any rewards anymore. So yeah, it's like around 4 million, right? Or around 3 to 4 million, what you have for one validator. And you see that some of these validator groups already are basically at capacity, right? You have here like 98% is cost of the votes, or 90% or 93%. So again, when we building the liquid staking protocol, elect such validator groups, we need to think about, do they even have the space available for us to be voting for them and then earn the rewards? So these are basically the two conclusions. Good. And then final word here is around the epoch rewards. So what do you actually earn as a holder that votes for different validator groups? So there are two parameters which reduce the amount of rewards that you receive when voting for a specific validator groups. That's first the slashing penalty. Well, if your validator group gets slashed, you earn less. And then the uptime score, so what we talked about before, right? That's more or less, it scales linearly. So if you have 80% uptime, well, you lose 20% of your validator rewards. And a big difference to a lot of other proof-of-stake protocols is that you as a voter, you cannot be slashed negatively. So the only thing, like if you vote for the worst validator, you get 0 rewards, but you never get minus rewards. The validator themselves, they get minus rewards, but not you as a voter. So like the good news is you cannot do that much wrong building out the protocol, but still you should optimize for voting for groups that have good scores here, right? Okay, and now about the technicalities around how is the voting and then the reception of rewards actually happening. So there are a number of steps that a user, if they vote without the liquid staking protocol, need to do. So first they need to lock Celo. That's like one transaction. Then they need to vote for a specific validator group, and they need to activate those votes. And you have basically time windows of 24 hours. And if you activate within that 24-hour window, only at the end of it, you start then earning rewards, and your votes are actually activated and contributing to the validator groups standing in the whole election cycle. Then afterwards, you automatically earn rewards. And the great thing is, like, it's automatically auto-compounding, unlike in other proof-of-stake networks. Then when you unvote, you first unvote, then you have to unstake. After you unstake, so those are two transactions. After you unstake, you need to wait for 3 days, and then you need to claim the Celo. So it's 3 transactions basically to get out of it again. And one technicality is also that one address that stakes. So if I stake my Celo, and now I have 100 staked Celo, I can maximum vote for 10 different validator groups out of that one single address. So again, when we built the liquid staking protocol, right, if we only have one smart contract, we can only vote for 10 validators. And yeah, the other important things is basically the 3 days that the unstaking period is. Okay, so let's go over to the liquid staking protocol. What are the main goals here, right? Why do we even need this, and what does it bring for users? So the first most important point is liquidity. If you stake your Celo normally, they are locked, and for Celo as well, this is a bad trade-off, right? Because these funds then don't contribute to the whole ecosystem. And then the second point is ease of use, right? So I described before, you need to know something about validator groups, you need to know something about uptime, you need to like survey these things all the time. You need to make like 6 transactions to vote and unvote. There are some UX problems here. And with a protocol, we can remove all of that. So all of this has basically nothing to do with the DAO, right? It's just a crypto protocol. And so basically the boundary condition, which I put here on the right, is that ideally we want all of this to be member-owned. So that's basically how Ethereum defines a DAO, right? You know, decisions, value, etc. It's all member-owned. So this is the core goal, that we can build this. Now we go into like the product management part. So basically, if we build the MVP, the goal is just to launch as fast as possible. That's the main goal. And the side goal is, well, we don't just want to launch anything. We want to launch something which has like minimal decentralization so that people feel confident enough that they stake their Celo through that protocol. And basically, on the left-hand side, we have like features or goals that the protocol needs to reach. So the first two are the main ones, right? Liquidity and ease of use. They were already postulated before. So the user should be able to stake their capital, and it should be simple, right? We don't want them to do 6 transactions. It should just be like 1 transaction in, 1 transaction out. And either via the protocol directly or by acquiring the liquid tokens on a DEX. And then we come to the more DAO type issues. So it should be member-owned regarding the code. So we want that contract upgrades from the protocol are owned by the members. And for the MVP, we say that we want upgrades to be made in a decentralized manners, and we want that users are protected against malicious upgrades somehow. So that's the goal. And now, how do we achieve that? It's pretty simple, right? You do a multisig. We do a multisig here 3 out of 5. And of these 5 people, actually only 2 people are with Celo. The rest is from the community. So Celo alone cannot even like make an upgrade. So that's quite okay. And then we have a 7-day time delay. So yeah, a lot of other protocols don't choose to do that, or because, well, you need to wait a week. But if you think about that, the unstaking takes 3 days. Basically, every user has 4 days time to realize that there is an upgrade happening and realize that they are not happy with it, and then withdraw their coins. And they should still be good. So I think that's pretty decent. The second point, which is around like the whole DAO and control part, is who elects the validator groups. So for blockchain, obviously, it's very important who the validators are and how decentralized that set of validators is, etc. So ideally, we would also want that just the holders of staked Celo, of the liquid staking protocol, could choose validators. But that's actually pretty complex. So what we did is we selected 8 validator groups that the protocol just votes for. But we did this in a more or less reasonable way, which I'm going to explain just in a second. And then the next few things are, well, we also want these people to be able to participate in governance of the layer 1. But this is complex, so we killed it for the first part. And we want scalability, like ideally all the Celos in the world should be able to be staked in this protocol. Again, that's complex because we can only vote for 8 validator groups in the beginning. And we've seen that the number of votes one validator group can receive is restricted. So at the moment, it's like restricted to around 15 million. But, you know, that's good enough to make a proof of concept. Okay. So how do we select validator groups? Basically, we selected 3 principles that we want to adhere to. We want to be efficient, means we want to select validator groups that perform well and therefore give maximum returns to our users. Then we want to be neutral, right? Potentially, this protocol could become very big. So a validator only needs 4 million Celo to be elected, right? I mean, that's not that much. the protocol could get this, and then we don't want to be like, as a group of 5, taking the decision, okay, this guy gets to become a validator and now earns 100K a year, and it's actually my body. So we want to be neutral, and we want to be credible as well. So we want to show our users that we don't just talk about these principles, but they can check that we actually followed through. So how did we achieve this? 2 simple steps. First, we created a short list of eligible validator groups. We clearly stated what the criteria are. So first, uptime score over 98%. Second, we wanted to have validators which have less votes, so the lower 2 tertiles. And why? Because, well, the mission is to have a decentralized network, right? And we don't want to vote for Andreessen Horowitz and Figment, which already are big and somewhat centralized. We don't want to have any slashing incidents, and then we want to have 2 million votes available at least, so that the 8 validators that we select return us like 15 million votes. So that gives us a short list, and then we randomly select 8 of those. And we do this with on-chain randomness, like we commit to a block ahead, we publish the hash, it's all out there, and then once it has happened, we can prove that actually out of the subset, which was also published ahead, we randomly selected the 8 validators that were chosen. So, I mean, it took some time to come up with like the process, but I can tell you in a small ecosystem, people are very driven around fairness, and everybody knows all these validator groups, and a lot of people are running validator their own, and everybody wants you to vote for them. So if you have a process like this, it really helps. So that was the MVP. Now we are building out the DAO version, basically V1, because it's not a full DAO. And I've marked pink here what has changed, or the most important things that have changed. So regarding the DAO aspects, right, the member-owned part, the code is now controlled by the users. So what we do is, first we thought about a governance token, but like that would be the full-fledged DAO service, basically. But I mean, launching a token these days, it's kind of maybe not ideal. At the moment, we have like 500,000 in the protocol. It's probably also not enough to launch a token yet. And also, engineering-wise, it's actually a bit of an effort. I mean, just launching a token is not a big effort, but then enabling the whole governance process and ensuring that like updates are really like only shipped if people vote and so on. Yeah, it is an overhead. So what we opted for is we decentralized the multisig further. So we kill the 2 people from C-Labs on the multisig, and we create a snapshot process so that holders of staked Celo can vote off-chain on what they want. And now that's very interesting. UMA has actually like an optimistic oracle for enabling snapshots votes to be processed into code changes. So we use that as like a work over for, instead of like creating a governance process on chain, basically. So this is a lot more lean, but I would say like 95% of the not security, but like guarantees that you get from on-chain, you basically have here too. So that's number 1. And number 2 is the validators. So ideally, we want to have users that can select their validator groups just individually. And what we did is, that's an error here on the slide. Like we changed how the validators are attributed. So basically, we enlarged the set of validators that are eligible, and people can just choose out of these validators which ones they want. And the reason for why people cannot just vote for any validator group is, again, that not all the validator groups perform well, but you as a holder of staked Celo, like if you vote for a validator group that doesn't earn anything, you still earn all the rewards that all the other validator groups earn, but you could just be voting for your own validator and still earn and decrease the APR of the overall protocol, and we need to prevent that. So that's why you can only select from the allow list. And regarding governance, yeah, we have enabled that, but interestingly enough, like this requires changes on the layer 1, like in the core contracts of the blockchain. So, you know, if you're just like a random project that wants to do that, it's actually pretty hard. Yeah, and then because we now have more validator groups, also the scalability problem is solved. So, to finish up, basically what I learned in this whole process is that initially it's pretty hard to share all decision powers with members of a protocol. So particularly if the project is built on, you know, an established system like a layer 1, like Celo, and this system is pretty hard to change. But